Hello, welcome to the Global DevOps Bootcamp. I'm Buck Hodges. I'm Director of Software Engineering for Visual Studio Team Services, and today I'm going to tell you about our journey from being a box product to a cloud service. The products I'm going to talk to you today, this journey that we've been through, is on Team Foundation Server and Visual Studio Team Services. What are those? Those provide Git, build automation, agile planning, release management, and the other tools that you need to do DevOps and do it well. VSTS is a service running on Azure in the cloud, and TFS is a box product that you buy and install yourself. So Visual Studio Team Services and Team Foundation Server are based on the same common code base. They are 90% the same code, or maybe even more than that. And that is key to our success. We have everybody work in master. The entire team today works in master. Every 3 weeks, which is the length of our sprint, we branch into a release branch, and that release branch then becomes what we ship into production on the service. And every sprint is the same length. They're always 3 weeks. They always start on a Monday, end on a Friday, and we start deployment to production the following Monday. After several sprints, 4 or 5 sprints, we create a release of Team Foundation Server and produce that literally from the release branch that we use to ship to the cloud that we have shipped to production. And we just repeat that cycle over and over again, each sprint shipping to VSTS and 4 to 5 sprints shipping to TFS, either an update or a major release of TFS. So let's rewind to 2011. The whole talk here is really about our journey, and I gave you a brief sense of kind of where we are to set some context, but I want to take you back to the beginning. So 2011 is the starting point for our service. And at that point, we had no experience with Azure. We had all of our data in SQL, which for TFS on premises was a good thing. Put everything in, all the data into SQL, makes it easy to back up, restore, and administer TFS. We had all of our authentication was Active Directory based. So we used Windows authentication. You had to be on a corporate network to authenticate with TFS. We didn't even have the notion of an account. So by definition, we were single tenant, which meant that in the early days, when we first stood up the service, every time you signed up for a new account, we actually created a new database. We got, in fact, to the point that we had 11,000 databases in Azure's North Central region. That was untenable, so we had to fix that. But our starting point was, again, this single tenant per DB. All of our upgrades were offline. We'd literally take the service down and run the upgrade and then bring it back online. And we'd do that at night on the weekends, during the weekdays, or usually on the weekends, because there's really no nighttime. When you're 24/7 in a global service, it's daytime for somebody. So we had to fix that. We also had next to no telemetry. Compared to where we are now, it was basically a rounding error. And so we were largely flying blind. This, by the way, was actually what got me to join Twitter. I figured if there was a problem with the service, that somebody would complain about it. So when we shipped the service at the Build Conference in 2011, and I knew we didn't have the telemetry that we needed, I figured if something went wrong, people would complain, and sure enough, that turned out to be true. So we also had no deployment cadence, which meant our deployments were random. We didn't deploy every 3 weeks. In fact, we didn't have a set of principles about when we deployed and why. So this was our starting point. We really were starting from scratch here with a box product and move into the cloud. So our very first step was to stand up a single instance. And this is Team Foundation Server, Scale Unit 1. That's what the SU stands for. And it's composed of, and still is comprised of, Azure PaaS, virtual machines, web roles, and worker roles. What we call ATs here are application tiers. Those serve up the REST endpoints and the web UI. The job agents do background processing. For example, when you check in a Git commit, you reference a work item in your comment. Those pick that up and process that. We have SQL databases, and there are n number of databases for a given scale unit, and Azure file storage. So as a difference from TFS, where we stored everything in SQL, with VSTS, we store some of our data in SQL, really the metadata, and everything else goes into Azure file storage. And that would include things like file attachments to your work items, Git repos, that sort of thing. And builds would be another good example there. So over time, we started to expand. So we started with a single scale unit. It had everything in it. And we had to extract the notion of an account service, identity, et cetera. We extracted that into something we called shared platform services. And this was key because this was the first real big evolution that would allow us to create multiple services. So we went from having a single instance to having 2 services at this point. The next thing we added was our own scale unit 0, which you might call a canary scale unit or a dog food scale unit. This is where the account for the VSTS team is hosted. And every change that we ship first through scale unit 0. And that way our team uses it first. And that is both valuable for us to be able to use new features and use them first and make sure they work well, but also to help find bugs. And that could be everything from performance and scale issues to correctness issues. We have an extensive set of tests, but of course tests are never perfect. And the fact that we can make use of it before the rest of the world, and we've got almost 500 people committing to that single master branch that I mentioned earlier, really helps us get a lot of mileage on the code directly ourselves before customers. And over time then we created more and more scale units. So I show here scale unit 7. There are actually now about 23 scale units of TFS. And these are now organized in a ring model. So we deploy first to ring 0, that's us. Ring 1, which has 2 scale units in it. Ring 2, which has several more, and so forth. And each ring encompasses a greater percentage of the user population. And that allows us to roll things out safely. One last thing I'll mention here is Shared Platform Services, SPS, has to this point been largely a singleton. Over the last year, a year ago, we set up SU0 for SPS. And this summer, we are in the process of creating all of the services that we need in order to create multiple instances of SPS. And so as we get into the fall, we will have multiple instances of SPS and have a ring model for deployment with SPS just like we do with TFS. So today, as I kind of pull us forward to what's it look like today, we've actually got quite a few services. We have over 30 services that comprise Visual Studio Team Services. TFS and SPS are still monoliths. SPS is being broken apart. And as I say, this summer, it is really going to become a set of microservices. TFS, we have plans to split that up, and we're starting with splitting out test case management. But all the other services that you see here are built as microservices. And as I mentioned, they're built on Azure PaaS VMs, but we are moving to Windows containers. This is a journey we started last year. We're continuing to make good progress on this. Hopefully, be it by the end of 2018 or early 2019, hopefully complete the journey to containers. So I'm going to rewind again and take us back to an early point of time with deployments. I mentioned before we had no cadence for deployments. And this diagram here at the bottom shows you what that looked like. So April 23rd, 2011 was sort of the birth date, if you will, of the service. That was the last time we stood it up from scratch. Everything else since then has been an upgrade. And then we did another update in August of 2011 ahead of the Build conference in September 2011, which was where we started unveiling the service to the world and handing out invitation codes for people to start using it. Those were very early days. And then we did an upgrade in December. Now that upgrade in December did not go well. It took us a couple of weeks to work through all the issues that we uncovered. And that was for us really the key indicator that the payloads were just too large. We're deploying so much change that trying to separate out what's good and what's bad, figure out where the problems were, became very, very difficult. So it was at that point we decided we're going to move to sprintly deployments. And we started this in early 2012. And again, we're early on to the service, so we still had a lot of issues. But getting to that regular cadence really was a key pivotal moment for us to get us onto a cloud cadence and really help motivate a lot of the changes that we've made since then, and some of which I will cover in this presentation. So our deployments were irregular. We switched those to being sprintly deployments, but we still had a problem with offline upgrades. So every 3 weeks, we're taking the service down to do an upgrade, be that on a weekend or a weekday night. And as I mentioned earlier, it's daytime somewhere. As I mentioned earlier, it's daytime somewhere. So we needed to get to the point that we could do online upgrades. Since we have both databases and application tiers and job agents, so we've got virtual machines and databases, as I mentioned earlier, they can't all upgrade simultaneously. So how do we do that? Something's got to be compatible with the old and the new and kind of handle that transition. And we decided the right thing to do there was to do that in the ATs and the job agents, because that allowed us to do it in C#. And in our case, since the language is C#, in yours it might be Java or some other language, but the concept still holds, which is it's much easier to deal with the differences between the old database and the new database in C# or Java, as opposed to trying to deal with it in SQL, where lots of if statements in SQL are terrible to deal with. They're hard to read, they're hard to reason about, they're hard to test. Also, we could have factory classes in the code that would match. Every sprint we create a new version of the SQL binder so that we know exactly what version of the database we're talking to. Each feature is responsible for that. And by doing that, it allows us to do easy rollback of binaries. So we deploy the binaries, and if something goes wrong, we can always flip back to the previous set of binaries. We do these blue-green deployments, as some people call them, where you spin up a new set of virtual machines, and then you swap those into production, and you swap the existing production machines out. And if something goes wrong, you just swap back. That's worked out really well for us. And as I mentioned earlier, it's hard to test SQL with a bunch of if statements. So it's easier for us to have tests to make sure we have the right compat with it done in the application tiers and the job agents. So the upgrade process is really three main phases. Step one, deploy the binaries. The binaries, in fact, carry the SQL changes. They carry the schema changes. They carry all of what's required for upgrade. But we don't initially start the database upgrade. So you deploy the new binaries, which is to say a new set of virtual machines, and swap them in. And once we're ready to move forward with the database side of the upgrade, which is to say we run a little bit of time on the binaries, make sure things are healthy, then we start the upgrade of the data. And this could be adding columns to a table, could be creating entirely new tables, could be processing and changing existing data. But we do all of that in preparation for the third and final phase, which is the schema upgrade. And this is actually done under a lock. And since it's done under a lock, because you can only have one version of a SPROC, you can only have one version of a table at a time, we want this to be an exceptionally fast operation. So this is just install the SPROCs and rename tables if you need to swap, let's say, a new table you created in with the existing one. And this happens under a lock. So you as a user, the worst thing you should see is a slight delay if you happen to, let's say, save a work item at the exact moment that upgrade ran for your account. And we have a timer. It's a strict timer. It has to go in 60 seconds or less, or we bail out and release the lock. So speaking of automation and speaking of deployment in particular, in the beginning, we didn't have automated deployments. We had this problem, if you will, in the team where people would say at the end of a sprint, hey, I've got this one-time command I need you to run. And a culture developed on the team where we wanted to collect these things. And so somebody created a OneNote, and for each sprint there was a OneNote with a set of instructions of how to do this sprint's deployment. And when you have, let's say 20 feature teams contributing code, you can imagine how quickly that grew. And the other problem with this, in addition to just the chaos that you get, which is kind of sending stuff around this way, is that OneNote, Outlook, Word, all of these tools like to help you out and make your documents look better, which is fine if you're publishing, not so good if you're trying to run something from a command line. So this call here, set options, let's imagine this is a PowerShell script that we're going to run. This won't actually run on the command line. Why is that? Well, those quotation marks aren't the normal ASCII quotation marks, but the fancier Unicode quotation marks that are curved. So you have to go through and replace this. So you're having to copy and paste commands from email or OneNote or wherever, fix up the quotation marks and any other issues, and run those. Well, you can imagine if you've got a dozen steps like that, you're going through this and you miss a step, that bad things are going to happen. And sure enough, we once broke pre-production for an entire day this way. We had about a dozen steps. A person messed up a step that was about halfway through. Nothing went wrong, nothing seemed to be wrong until we got to the very end and pre-production no longer worked. And it was that experience this was in the summer of 2013, that made us look at it and go, this is crazy, we have to change. And at that point we said, we're going to automate deployment completely. No more one-time commands, no more sharing commands through OneNote, no more sharing commands through email. Every command goes into the repo, gets checked in. So it's scripted via PowerShell, typically. So those PowerShell scripts get checked in to that repo, and that allows us to make sure that every single time we do deployment, whether it's to pre-production or our Canary instance or any of the other instances, that they're always the same, and takes out that variability of humans having to do it. I mentioned earlier that we now have 23 instances of TFS. All those other 30 services that I showed you, there are multiple instances of all of those too. And as you imagine, this kind of explodes quickly. So it's also just not even feasible, humanly feasible, to keep up with all of this, doing it manually. So it has to be automated. And one thing I want to point out here is we actually do releases of VSTS with VSTS. We believe very strongly that we want to dog food every part of the product. This also, by the way, does mean that we do know how to deploy VSTS if VSTS is down. This is kind of a unique chicken and egg problem here, but we use release management to deploy VSTS, just like we use it for all of our agile planning, build automation, the code, etc. So now that I've got deployment automated, I've got a different problem now. I mentioned we're all working in a single master branch, and engineers are checking in code, checking in features as they are ready in order to avoid integration debt of having people in separate branches and trying to bring it all together. But we need some way to control exposure, and feature flags allow us to do exactly this. So in the diagram here, you've got an existing block of code, in this case colored purple, with a path through it, and we go add a new piece of code that has a new capability, and it's not actually turned on, but we implement this code in the green block, a new functionality, new feature, and now when we flip a feature flag on, we have the code now, the code path is now going through the green block rather than the purple block, and over time, if we like the code, we can in fact completely remove it, and therefore switch to the new path, which becomes permanent, take the feature flag out, and delete the old code. And this is really important for us. This is a great mechanism for feedback and experimentation. Feedback meaning we can turn it on for progressively larger sets of people. We can ask for feedback when we turn a feature off or on. We can actually allow customers now to control it. If you've ever used Visual Studio Team Services and clicked on your avatar and picked preview features, you're essentially enabling and disabling your own feature flags for your own experience via that panel that shows up. And when something gets turned off, we ask you for feedback because we want to know, what caused you to turn it off, and that we can learn from that. It allows us to decouple marketing and engineering, and this is really important. We can develop features and ship them when they are ready, but then marketing can decide when to expose them to customers. That could be, for example, for a conference. And that's particularly important to provide a lot of agility for the team. As I mentioned, we expose this to different sets of people, so we have defined stages for our feature flags to roll new features out. And that means we have control down to the individual user. So we can change a feature flag for a scale unit, for an account, for a user, a great deal of granularity there that has provided us lots of value. And one last thing here that's super important is we can make changes to feature flags with no deployment. We make a change to a feature flag, it's reflected in the product immediately. I mean, close enough, right? Within a second or two, it's propagated everywhere throughout the whole system. And that's really, really flexible because it means that you can do them instantaneously nearly. You don't have to wait on a brand new deployment of the service to see these changes take effect. Now, all this sounds awesome, but what could possibly go wrong? Well, we found out the hard way. So we had a bunch of features that we wanted to reveal at a big conference, a big event actually, in November 2013. It was the Connect event in 2013. And we made a big mistake here. We decided we were going to hold on to those features tightly and not show them to anybody. And so shortly before the keynote, about an hour and a half before the keynote, we flipped on a bunch of feature flags, and it did not go well. We had problems that took us, in fact, a couple of weeks to go sort through and fully get to root cause. It was pretty miserable. And that taught us a number of key lessons. First is, always turn feature flags on at least 24 hours ahead of an event. And that way, if something goes wrong, you have time to react and do something about it. And maybe you can't fix it in time for the event, but at least during the event, you're not experiencing the problem as we were during this event. We now turn them on incrementally. Don't flip two dozen feature flags on at the same time. It sounds blindingly obvious, telling you about it now, but at the time, we thought, hey, we need to keep all of this under wraps, and this was an important lesson. Third thing is monitoring and really making sure not only that there aren't errors, but in fact that the feature is working correctly. One of the key things here about DevOps is the absence of errors doesn't mean success. The absence of errors is a good indicator. What you really want to know is the feature actually working correctly. And then last but not least is that we use feature flags for back-end changes. Most of the time when people talk about feature flags, you associate it with an end-user feature, a new button or a new capability that shows up to the end-user experience, but it doesn't have to be. And so we have used that for back-end features to be able to, for example, selectively roll out new capabilities. This becomes really interesting if you're going to try to enhance an existing capability and slowly roll it out and compare the results of before and after of using it with the old implementation versus the new implementation. Feature flags serve a really valuable purpose even for things that aren't visible to the end user. Now, in that set of issues we had at the event with feature flags, we had this nice graph. How do we get all of that? Well, this was another big shift for the team. We had been used to developing a box product, shipping it to customers who installed it and would run it themselves, and therefore we didn't have much in the way of telemetry. I said early on we had no telemetry at the beginning, and while it wasn't literally true, it was close enough to the truth. And so this was a big mindset shift for the team of really realizing, hey, everything that you consider important to be able to diagnose, debug, and figure out what to mitigate when there's a problem, because certainly as soon as possible you want to mitigate an issue for a customer. We need to capture a lot of data, and that includes capturing perf counters, capturing trace statements, using these things to create availability models, do alerting, create dashboards, really get visibility into your system. And today, we're now collecting more than 7 terabytes a day of data about what's going on in Visual Studio Team Services. And truly, telemetry is the lifeblood when it comes to running a live site, running a service, and really doing DevOps well. Telemetry is key. Without it, you're in deep trouble. So the last thing I want to touch on here is our test transformation. So we started as a box product team, shipping every 2 to 3 years. We had a set of test collateral that was really optimized for that, or okay, maybe optimized is too strong a word. I will say it was a test collateral that would work with that long cycle. We needed to be able to ship more quickly. We had moved to 3-week sprints already, and we realized it was time to transform our whole test code base. And so we came up with a set of principles that would address some of the key pain points that we had. One is to test at the lowest level possible. We had a lot of automated tests that were written as end-to-end scenario tests, and this wasn't serving us as we needed because they took a long time. We had nightly automation runs that took more than 22 hours to run. It's no longer nightly, it's more like once a day at best. And they weren't very reliable. So we wanted to change that. We wanted to make them fast. We wanted to make them reliable. We started doing reliability runs where we'd take a build that had passed a core set of tests and just run it in a loop to find and fix the flaky tests. We wanted the product to be designed for testability. And that really means that if you're writing the code and you're writing the tests, that you're on the hook to make sure that the code is testable. Otherwise, you're going to have a lot of extra work to go do. So there's really a good feedback loop. And this is tied to, by the way, to the change that we made about 4 years ago to merge development and testing into a single software engineering discipline. And this provides a nice tight feedback loop. So if you're writing your code, you have a lot of motivation to make it testable. We wanted to treat test code as product code. And in the past, this wasn't always the case, but test code is as critical as the product code. We want it to be well designed and run and execute very well. So tying all that together, we use pull requests for code reviews at Microsoft. And what this allows us to do is when you submit a pull request, we queue a build, and that build automatically starts as soon as the pull request is created. And as part of that build, we run unit tests. And so all of these tests that we had completely revamped You can see here we run over 64,000 unit tests here in about 6 minutes and 49 seconds. So it's a tremendous amount of code coverage here on every pull request before that gets merged into master. And pull requests in Visual Studio Team Services have a great feature called autocomplete. So you can set your pull request to autocomplete, which means that when your code review is completed, your build is completed, the tests have run, it automatically merges into master for you. And this is how we keep the master branch at high quality with almost 500 people committing code into master. So in summary, we have constantly been evolving in production. We started with TFS, we started with a single instance, and we've refactored out of that shared platform services, and then since then have built a host of microservices around it. We now have fully automated deployment, which has been critical not only for quality, but also just scaling out with the service as it's grown very, very rapidly. We've embraced telemetry. Telemetry really is the lifeblood, as I mentioned, of a life site and DevOps. And we collect an immense amount of data on the service. And last but very much not least is reliable and fast tests. This has allowed us to move more quickly with higher quality and has really made a huge difference in how we work every day. So I want to thank you for being here. If you would like to learn more about our DevOps journey, you can go to aka.ms/DevOps. There you will find a series of videos that we recorded recently that will help you understand in greater detail about these topics and many more. I hope you have a lot of fun today learning DevOps.